Hi, everybody, and welcome to our second webinar in a series of nitrosamine testing that we've been doing. In this one, we're going to take a look at how the ATNA fits with nitrosamine testing. So I'm now going to hand over to my colleague who's going to run through the presentation and take you through.
So as Andrew said, we're going to be talking about how the ATNA fits with nitrosamine testing. So what are we going to talk about? Well, first of all, what is the ATNA? How does it work? Automated nitrite, nitrate, and nitrosamine analysis. Where and how the ATNA can be used. So ATNA stands for Automated Total Nitrosamine Analyzer. Nitrites, nitrates, nitramines, and nitrosamines can all be detected using this system. It uses a chemical reaction to release the NO, and it then gives us a molar response for the NO molecules present. So in pharmaceuticals, they generally discuss the nanograms of NO present. In the cosmetics industry, they typically discuss it as a number of nanograms of NNO from the nitrosamine. Just as an aside, the nitrate molecule is more stable than the nitrite or the nitrosamine molecule. So less NO is released from the nitrate than the others. Therefore, we have a lower sensitivity to nitrate than nitrite or nitrosamines. So these are the chemical reactions involved with the detection. As I said, we use a chemical reaction involving hydrobromic acid to release the nitrosyl radical, or NO. This passes through into the TEA where it is reacted with ozone from the built-in ozone generator to form an excited state of nitrogen dioxide, or NO2. When the NO2 relaxes, it releases a photon of light, and that is what is actually detected by the TEA. So we are a chemiluminescent detector for the NO molecule. And this is going to be a short video on a typical analysis, and in this case, of a tablet. The sample is ground to increase the surface area for the extraction. We weigh it into the extraction vial, add solvent, and extract. We then centrifuge to pellet anything that hasn't dissolved. We then pass the sample through a particulate filter. We then aliquot into the reaction vials, add our reaction mixture, which contains a hydrobromic acid, cap it, place it on the autosampler where it is vortexed, heated, vortexed again just to help liberate the NO into the headspace of the vial. The sample is allowed to cool, and then it is injected into the custom TEA inlet for analysis. Now, if you do have a high concentration sample, you can simply dilute the extracted sample and then reanalyze it. So this is a typical sodium nitrite calibration curve. It's gone nonlinear. So if we split it into two linear cal curves, then we can quantitate the nitrite present. Reproducibility of sodium nitrite, 1 ppm and 100 ppb. Sodium nitrate, calibration curve, and reproducibility. Once again, 1 ppm, 100 ppb, and as I was saying earlier, the sensitivity towards the nitrite is greater than the nitrate. So this is 1 ppm sodium nitrite, 100 ppb sodium nitrite, 1 ppm sodium nitrate, and then 100 ppb sodium nitrate. As this system gives a molar response for the NO present, any standard can be used to construct a calibration curve. Typically, we use NDMA, but you can also use Ndela or any other nitrosamine that you wish. We typically see a very reproducible rise for our blank. We can make this worse, we can't really make it better. It's probably a nitrite contamination somewhere in the vials or the glassware, but that is a very reproducible trace analysis. 0.5 ppb, 1 ppb NDMA, calibration curve for NDMA. Now, notice we say that this is 250 nanograms per mil of NDMA. From the molecular weight of NDMA, we can therefore calculate the absolute number of nanograms that were present in the vial to construct the calibration curve. Reproducibility of NDMA standards at 1, 5, and 50 ppb, and then the results for them. Now, this is an external standard headspace method. We can't add an internal standard because all we're doing is detecting the NO molecule present. So this is the absolute variation throughout the entire process. So why is it important to differentiate between the nitrites and the nitrosamine? The formation of nitrosamines occur with the reaction between an amine and a nitrating source. If you don't differentiate between the nitrites and nitrosamines, then the ATNA will give you the worst case scenario. So if all of the amine present reacts with all of the nitrites present, this is how much nitrosamine can be formed. Now, sulfamic acid has been traditionally used to remove the nitrites during sample preparation. However, at low pHs, as in the pH where we're adding the hydrobromic acid during the chemical strip reaction, the nitrosamine can also be affected by the sulfamic acid present. So at Ellutia, we've been developing a secondary reaction mixture, a nitrite reaction mixture, and this reduces nitrites to NO, but does not react with the nitrosamines. This can either be used in sample preparation or the sample can be analyzed. Because let's face it, this data is also quite valuable as this will give you an idea of, once again, the worst case scenario. If the nitrosamine is formed during storage. And then subsequently, we add our hydrobromic acid reaction mixture, and then you can see NDMA from both the sodium nitrate plus NDMA standard. And also from the NDMA standard without the sodium nitrite. And then once again, the sodium nitrite is then giving us a blank response with the hydrobromic acid. From this, it appears like we're removing the vast majority of the nitrites present. What's the advantage of this? Well, the ATNA system will give you one result for the apparent total nitrosamine content, or the ATNC. Both volatile and non-volatile nitrosamines can be detected in a single injection. There's no separation of analytes, no resolution, no GC, no LC, none of that at all involved. So this is a quantitative, not qualitative analysis. If you have positive samples, they can be quickly identified for further speciated analysis. The advantage here is the throughput is about 6 samples an hour as opposed to about 2 samples an hour from your typical GC or LC MSMS system. As I was saying, this can either give you a result as an NNO concentration or an NO concentration based on the molarity of the NO or the NNO group. Okay, so 1 milligram per liter of NDMA contains 60 milligrams a liter of the NNO molecule. However, 1 milligram of NDELA, as it weighs almost double NDMA, the relative proportion of the NNO molecule is about half that of the NDMA. Uses. Why pay for a reagent or a solvent or an ingredient? Have your staff formulating a product, costing time and money, only to then have to pay for the disposal of a contaminated product. So an incoming QC, the solvents, the water, the excipients, they can all be screened quickly for the presence of a nitrite, nitrate, or a nitrosamine. In a finished product, the ATNA total result gives you the worst possible concentration of nitrosamine formation. So how many nitrosamines that can be formed during the standard storage conditions. If there are nitrites present in the excipients, for example, then this will aid you with your risk assessments as it will give you the worst case scenario. If everything reacts, then this is the concentration of nitrosamines that will be present. This kind of approach has been used in the cosmetics industry for many years, and we already have a system that is undergoing tests with the FDA to gain FDA approval for this approach to nitrosamine testing in the pharmaceutical industry. But it's not a silver bullet. If you expect most of your samples to be below actionable levels, then yes, it's a great way of saving time, effort, money by doing a rapid screening technique. If, however, you're expecting most of your samples to come back positive, therefore you will have to speciate most of your samples, then you might as well just move straight to the speciated analysis. So is there value for a simple, quick, reliable test for incoming excipients, raw materials for the presence of nitrosamines in formulations? The same system can be used for screening formulated products, excipients, solvents, water, washes, everything throughout every process of the formulation process to ensure compliance with all legislations. I hope you have found this of interest. If you wish to have any further information, please contact us at the email address shown. Thank you for watching.